Okay, guys, we're going to work through our last way to solve a system of equations, which is our final technique, which is solving systems by elimination. So we solve by graphing, where we look for the point of intersection. We solve by substitution, where we solved one of our equations for a variable and plugged it into the other. Now we're going to solve by our last method, which is elimination. So here are the steps for using elimination. And this is important, and make sure that you write down these steps. When we're solving a system of linear equations by elimination, step 1, multiply, if necessary, one or both of the equations by a constant, so at least one pair of like terms has the same or opposite coefficients. So what we're going to be looking for when we're dealing with solving by elimination is we really want opposite coefficients in at least one of our variables. Once we have that, then we can go ahead and we can use elimination. We're going to primarily be using addition. I think it's easier to add, so we're always going to be looking for those opposite coefficients and adding them. Could you subtract the two equations from one another? You absolutely could. You just have to be careful about your signs. Step 3, solve the resulting equation. Step 4, substitute the value from step 3 into one of the original equations and solve for the other variable. So similarly, what we're going to be looking for is that point of intersection, and our answer is going to be an ordered pair. The key thing you need to maintain when you're dealing with these solving by elimination, you want it in standard form. That's ax plus by equals c. And we're looking for opposite coefficients. So let's take a look at our first example here. So it says solve the system of equations by elimination. Now notice here, we prefer graphing or substitution when we have something like y equals or x equals. In both of these equations here, I don't have that. They're written in standard form, ax plus by equals c. So you need to be able to recognize which method is the best one to use. When you see something in this form, elimination is the best method to use here. And what we're looking for is we're looking for opposite coefficients of the same value, which you see here with 2 and negative 2. So in this particular problem, you don't even have to do step 1, which says multiply, if necessary, one or both of the equations, so we have opposite coefficients with one of our variables. Here, we have opposite coefficients with the positive 2 and the negative 2 right there. So when that's the case, whether it's with my x's or my y's, right away we can go to adding these two equations together. And the reason we call this elimination is you're eliminating one of your variables. So when I add these two equations together, 2y plus negative 2y, my y's cancel out. And I continue and I add everything else together. So I have 3x plus 4x, which is going to be 7x. And I have 4 plus 10, which is going to be positive 14. From this point, we solve for one of our variables. We're going to get x is equal to 2 here. So I have my x value equal to 2. If I go back to my steps, we've solved the resulting equation. And now we have to substitute our value, in this case x, into one of our original equations to get my y value. Doesn't matter. You can substitute it into the top or the bottom. I'm going to substitute it into my top equation here, and I'm going to solve for y. So 3 times my x value, which is 2, plus 2y is equal to 4. 3 times 2 is 6. 6 plus 2y is equal to 4. Subtract the 6 from both sides. You're going to get 2y is equal to negative 2. Divide by 2. And you'll get your y value equal to negative 1. So remember, your answer is always a solution here. Here, my answer is the solution with the point 2 comma negative 1. If you wanted to, you could check your answer. You could check your answer by plugging 2 comma negative 1 into both of your solutions. You could check it by graphing, but you need to know this technique of solving by elimination. So key steps, first, make sure it's in standard form, both of your equations, ax plus by equals c. Once you've gotten it in standard form, you're looking for opposite values of your coefficients. So let's take a look at our next example. Good news for us, they're both in standard form here. And also good news for us, I see we have opposite coefficients this time with our x's. I've got a 2 and a negative 2, which is ideally what I want. So what am I going to do? I can just add my two equations together now. What's going to happen this time? The x's cancel perfectly fine. 15y plus 9y is 24y. And negative 24 plus 24 is equal to 0, which is perfectly fine. You can be equal to 0. Divide by 24, and 0 divided by 24 is just y is equal to 0. Y can be equal to 0. 0 is a point on our coordinate plane. 0 is allowed to be in the numerator, so I have a y value equal to 0. Plug into either one of your equations, doesn't matter which one. Today I feel like plugging into my bottom one, and I'm going to plug it in for y. Make sure you plug it in for the correct variable. So then you're going to get 2x plus 9 times 0 is equal to 24. Well, 9 times 0 is just 0, so I'm going to get 2x is equal to 24. Divide by 2, and you're going to get x is equal to 12. So there's my x value. I already had my y value. My final answer, these two graphs would intersect at the point 12, 0. My x value equal to 12, my y value equal to 0 is my solution. That also happens to be the x-intercept. Okay, so those were nice and easy because we had variables that were going to cancel right away. Lots of times that doesn't happen, like you see in example 2 here. So notice in example 2, nothing is going to cancel right away. Right? I have a negative 6 and I have a negative 4 with my x's, and I have a positive 3 and a negative 6 with my y's. So nothing is canceling here. When that happens, you need to multiply one or both of your equations in order for something to cancel. So in order to have opposite coefficients. So if I see negative 6 and negative 4, there's nothing too easy right away that jumps out to me. Maybe to you there is, but not to me. But if I see I have a positive 3 and a negative 6, I know I can take my entire top equation and multiply everything by 2. Why am I multiplying by 2? Because when I multiply by 2, my 3y is going to become a positive 6y, and then I'll have opposite coefficients. So my new top equation is going to be, and I have to multiply that 2 times everything, negative 12x plus 6y, and don't forget to multiply it times the right side as well, is equal to positive 10. My second equation, I don't have to change anything here. Negative 4x minus 6y is equal to 22. But remember, my whole goal is to have opposite coefficients, which I have right now. I have a positive 6 and a negative 6. From this point, take your two equations, add them together. My y's will cancel, which is my goal, always eliminate a variable. Negative 12x plus negative 4x is negative 16x. 10 plus 22 is 32. Solve for x, divide by negative 16. You've got x is equal to negative 2. So there's my x value. Take your x, plug it into whatever equation you feel like plugging it into. I'm going to take it, I'm going to plug it into my top one. And I'm going to solve for y. So negative 6 times negative 2 plus 3y equals 10. Oops, equals 5, sorry. Now, I plugged it into my original. Could you have plugged it into my new red equation? Sure, you absolutely could have. Doesn't matter where you plug it in. So now I've got 12 plus 3y is equal to 5. Subtract the 12. You've got 3y is equal to negative 7. And y happens to be a fraction here. That's perfectly fine. Y is equal to negative 7 over 3. As a decimal, that would be negative 2.33 repeating. Perfectly fine. Nobody said your values have to be whole numbers. They can be fractions. So our final answer, our x value is equal to negative 2. Our y value is equal to negative 7/3. And there's my solution. Could I graph it and check it? Sure. Could I plug it back in and check it? Sure. Whatever you want. One more example to look at, okay? And we're looking at this example. We're saying to ourselves, ooh, this one's rough because I have a 4 and a 6 with my x's, so they're not going to cancel right away. I have a -5 and a 7 for my y, or a 5 and a -7 rather for my y's. They're not going to cancel right away. So in this particular problem, you have to multiply both of your equations, and you're looking for multiplication to lead to something you could eliminate. So in essence, what you're looking for is you're looking for the least common multiple. You're looking for some value that you can get either your 4 and your 6 to, or your 5 and your -7. You could always just multiply the numbers together, like 4 and 6, and get 24. You know 24 works. Or 5 and -7, you can get 35, and that would work. But we want to keep our numbers small. So I'm saying to myself, wait a second. If I multiply the 4 times 3, I can get to 12. If I multiply 6 times 2, I can get to 12. And then I can cancel from there. But I want one of those to be negative. So I'm going to make my top one negative. So I'm going to multiply my entire top equation by -3. And then I'm going to get -12x minus 15y is equal to -18. Now my bottom equation now, I was saying to myself, okay, I'll just multiply that equation by 2. A positive 2. And then I'll get a positive 12x. 2 times -14 is, or 2 times -7 rather is -14, so -14y. And then 2 times -20 is -40. Now I'm happy because now I have a positive or a -12x and a positive 12x here and here. And now I know I can just add my two equations together. Now, could you have gone a different route? Absolutely. Could you have multiplied the top equation by +7 and the bottom equation by +5 and then eliminated your y's? Certainly, that would have worked as well. There are different ways that you could have done this. -12 plus +12, that'll cancel. -14 plus -15 plus -14 is -29y. And then -18 plus -40 is -58. Divide by -29. This works out nice and even. -58 divided by -29 is a +2 for y. So there's my y value. Take it. Doesn't matter where you plug in. I'm feeling the top one right here. So I'm going to get 4x plus 5 times my y value of 2 is equal to 6. 4x plus 10 equals 6. Subtract the 10. You're going to get 4x is equal to 6 minus 10 is -4. Divide by 4. And you get your x value equal to -1. So our final answer is the ordered pair, -1, 2. Now, I want to show you just quickly, you could have, like I said, multiplied the top equation by 7 and the bottom equation by 5. In that case, we would have gotten 7 times 4, 28x, plus 35y, equals 6 times 7 is 42. Then our bottom one, multiply everything by 5, and you're going to get 30x minus 35 equals, and then -20 times 5 would be +100 rather. Oh, times 5, -100. Sorry. Now, here, my y's would cancel. You end up getting 58x is equal to 42 plus -100 is -58. Divide by 58. And look what happens. You get that same x value equal to -1. And then we could have gone and gotten our y value as well. So I wanted to show you there that it didn't matter. If you wanted to try and cancel your y's, you're going to end up getting the same answer for that. We'll do a bunch of try these examples in class, and we'll look at example number 3, which is our word problem, then as well. All right? Good luck. If you want to try example 3 on your own ahead of time, feel free, and I'll see you in class.